Today, my name is Yahya Ithawi. I am a consultant neonatologist and I'm a research advocate. And this is the fourth sessions of a series of sessions about research. We started with generating questions, then reading research articles, and then last session was about hypothesis testing. Today is about sampling, sample size calculation, and randomization. So my objectives in this session is to do some definitions and then talk about the attribute of sample size. And then we will compare the large versus small sample size. And we'll talk about two ways of sampling, probability sampling and non-probability sampling. We'll talk about level of significance and power of the study and expected effect of size of sample on the sample size. And also the event rate in the population or the prevalence, and how we will calculate sample size. We'll give examples about sample size calculation, and then we'll do what is the sampling methods, and at the end we'll do some randomization. So I'm gonna kick off with a question, is what is the difference between population, targeted population, and sample? Anybody want to answer? You can unmute yourself and answer the question. Any volunteer?
Dr. Yahya, can I talk?
Yes, go ahead, please.
For example, if I want to do research in a newborn, population will be newborn. And if I put a criteria for which baby will be included, will be targeted population. And from this targeted population, I will select the sample.
So what is your population?
My population is whole newborn, will be admitted to in ICU, for example, in the Palestine.
Yes. The population is babies admitted to newborns. Okay, targeted population.
Yes. Yeah. Targeted population, according to my criteria, will be including criteria. This target population will be. I will say this my including criteria. Whole baby.
Let's make it easy. Premature babies.
Yeah, premature baby. For example,
that's your target population, and what's your
target population? Sample accordingly. For example, will be admitted to an ICU. For example, 1,000 premature baby. From this 1,000 premature baby, I will select. I don't know, some randomly, systematically. Okay. I will select the sample to represent my population.
Yeah, thank you very much. Yeah, just mute yourself. Thank you very much. You're absolutely right. So before we say the population, we will talk about sampling. What is sampling? So sampling is a selection set of individuals to adequately represent the inferencing population. Okay, while population is, you guys hear me? Okay, so population is a complete set of population. There is no difference. All of them are included. Example, Japanese. Targeted population is the subset of population that have specific clinical and demographical characteristics. On those, we want to apply the intervention. While sample is a set of targeted population that actually will receive the intervention. So not all the target population will receive, but a subset of them. So what is the probability of sampling? Anybody want to answer?
Can I respond?
Yeah, go ahead.
Probability meaning every element of this population has a chance to be selected.
Correct, that's one. Any other thing? Okay, so let's continue. You're 50% correct. So mute yourself, we'll continue. So probability sampling means every member of the population has the chance of being selected. Okay, and it represents the probability of sampling. When you apply a test, it represents the whole population. Okay, so probability sampling is every member of the population, every subject of them has the same chance of being selected. And second is the result of the sampling can represent the whole population. So what is sampling? We've talked about it. Sampling is when you have a population, you see that there is a population of different characteristics, there is different colors. And then you go to targeted population, so population with one character, which is the black. And then you take sample of them to represent the targeted population. That is called sampling. So you select a subset of individual from individual with certain characteristic at which you apply the intervention that you can infer it to. So you selected a sample size from the targeted population on which you will apply test that you can infer it on the targeted population. That's called sampling. Now the attribute of sample size. The attribute of sample size meaning that each individual of the population has equal chance of being selected. What does that mean? Let's assume the population are 10. Then you selected 1. The remaining is 9. The 9 will not be affected by the fact that 1 is gone. So they have still the same chance to be selected. And when you selected 1 again, the remaining is 8. The chance of 8 being selected will not be different from the 1 and 2. So every member of the population has equal chance to be selected. The second is the choice of participant should not affect the chance of another person to be selected. So if I select 7, 7 should not affect 6 and should not affect 5, should not affect 1. The other things of the sample size attribute is the sample size calculation should be calculated before the first subject being recruited or enrolled or receiving the intervention. So these are 3 factors called attribute of sample size. Now, there are 2 types of sample size. There is big sample size and there is small sample size. Now, the small sample size cannot be generalized. It cannot infer to the targeted population because they are small. They are not representative the whole heterogeneity of the targeted population. And therefore, we cannot compare or test the difference between those at risk and those at non-risk. What are the drawbacks of large sample size? Anybody want to answer? No? Okay, well, let's continue then. Large sample size, or Rasha want to answer. Go ahead, Rasha. Unmute yourself and you can answer. Rasha. Yeah, go ahead.
Hello. Large sample size can be generalized to the population more than the small sample size, resulting in more bias. Also, the
question is, what is the drawback, not the benefit of large sample size? What is the negative size of large sample size?
More costly, more time-consuming, difficult.
It's expensive. As we said, we talked about China. It's 1 million, 11 million sample size. It's a lot of expense. Yeah, it's very expensive. Yeah, that's the answer. So it's very expensive, and it exposed lots of people to the intervention. So it's somewhat unethical to expose big size population to the intervention. Okay, and it's unethical, and then it's a waste of resources. You know, research time, money, manpower, and so on. So what are the factors affecting sample size? Tariq asked the question at the beginning. Anybody want to contribute?
Dr. Yahya?
Yeah, go ahead.
I think the most important one is inclusion criteria, isn't it?
Yes and no. Yes, indirectly, but no directly. Any other thing? Okay, well, let's ask other. Rasha, want to answer? Go ahead, Rasha.
Yes, doctor. If the disease or some if any rare disease or chronic dominant disease, then the sample size will be affected. Also, the general population, if the large population and target population is large, we should take more than more large sample than other disease
Okay.
or.
Okay. Rasha, thank you. Any other thoughts?
Again, Dr. Yahya, I think resources, if we have, as mentioned before, if we have limited resources, we cannot take large sample size.
Correct. It can affect the sample size. Yes. Any other thoughts?
Also power of the study.
Power of the study. Yes, that's very important. Yes. Any other thoughts?
Confidence or significant level of significance.
Significance level, not the confidence interval. That's a confidence interval is different from significance level. Okay.
Also the proportion of sample.
The proportion of the sample. I don't know what does that mean.
That means the percentage.
Yeah, I don't know. Yeah. Any other thoughts?
Type of the study.
What?
Type of the study.
Type of the study. Yes and no. Okay. Well, let's continue then. Thank you for the contribution. So.
And error, the error also, and the factors also. The error can also.
The error or the error?
Error.
I don't know what does that mean. Okay, well, let's continue. Thank you for the contribution.
Resources.
So the first one, the size is level of significance. The second is the power of the study. The third is the expected effect size, the difference of between the 2 arms or 3 arms or 4 arms. What are the difference between them? And what is the prevalence? What is the event rate in the population? What is the percentage of targeted population from the population? What is the standard deviation or the variance, the stretch out from the median? So you know that the sample size can be, the mean or the median can be 10, but 10 can be a mean of 1 to 20, but also can be a mean of 9 to 11. So 9 to 11, very small standard deviation, while 1 to 20, large standard deviation. So the stretch of the population, the variance from the mean or the average also contribute to the effect size. The concentrate, like how confident that from the recruited to enrolled, how confident that you get all of them. And the dropout, when you lose the sample, like person or the patient being troubled or transferred or died. So the question here, what is the difference between the power of the study and the significance level? Now, we've talked about this loads, so I don't want you to answer. It's a very complicated complicated answer, so I'm going to answer it. So level of significance, or what we call it, the probability level, and P stand for probability. So as we said, we accept the p-value of being less than 0.05 or 5%, which means at that point there is a difference, but we think that difference is attributed to chance. So we are okay to ignore that difference despite it is present, but we thought it's due to chance. And that at that point, we reject the null hypothesis. We accept the alternate hypothesis. So we're willing to lose 5% despite it's positive. So that's why we call it, it's a false positive. So, and this is the You can see here is 95%. The alternate hypothesis is accepted, and 5% the null hypothesis. It should also be accepted, but we're losing it due to chance. So here's the null hypothesis is rejected, and that's called its significance level, or these 5% is the by being positive. Try to mute yourself, please. So I mute all. Okay. The 5%, despite being positive, but we are ignoring it, we're accepting not to conclude it, so it's positive, but we are not taking it, so it's false positive. Now, the power of the study, here's the power of the study. So this data, okay, it's positive. Alternate hypothesis is acceptable, it's significant, but we're losing it. So we're not including it. We're not calculating it. So it's negative. And because we are not negative, we call it false negative. And usually it's 20%. And therefore, the power of the study is 1 minus p. And most of the study, by convention, we accept 80%. The power of the study, and again, is the percentage of data that we think we're losing, but we are okay. And we are okay losing most of the study. We're okay losing about 20% of the data. Okay, and that's called beta error. It's negative data. We are losing it, but we know we are losing it, so it's false negative. So the question is here, what is the effect size? Any thought?
What is the effect size?
Well,
I think the difference.
Wait, let me answer Manal. Manal is asking, why is 20% part of the study? Does this have a significance? Now, the power of the study has nothing to do with significance. The significance is a different issue. The significance, there is effect, but we are ignoring it because we think it's due to chance. So the less this effect, the more the significance. The power of the study is the less we lose data, the more power the study. So there are two different things. Is the power of the study is the how much data we are losing, but we don't know how we are losing it. So if we're losing 20% of the data, we're accepting it because we say our power is 80. We are keeping 80 of the data and we're losing 20. So that's called beta error because it's false negative. It's a negative data, we're losing it. It has nothing to do with significance. Significance is positive data. We know it's there, we know the difference, but we are ignoring it because we think it's chance. So Manal, the power of the study, why 21? Yeah, it's a good question. It's by convention. We don't know why. It's by convention, people accepting that. Okay, why we think, for example, male should put pants and female should put skirt. Why? We don't know, because that's a convention. Why male make short hair and women make long hair? We don't know. Why man does not put makeup, women put makeup? Why? It's by convention. We don't know why. That is norm. That is the norm. So we accept by convention 20%. So you can mute yourself. Okay, so by convention. Now 20% is the minimum, but we can only you can use a power of 15% or 10%. The less the error, beta error, the more the power, then the better the study, but bigger the sample size. So you can say, I want 100%. I don't want to lose any data. Meaning you have to use the whole population. So the more powerful the study, you say 95, the beta error is 5%, then that's more sample size you need. You can say, no, I want 100% power study, then you have to include all the targeted population. You don't do sampling. So why 20? That is the minimum accepted. It's like the significance. Why 5%? It's by convention. There is no reason why. Okay, so the question, I hope I answered you, Manal. What is the effect size? Any volunteer?
I think Dr. Alam, effect
Yeah.
size depend on two arms.
Okay, the difference between two arms. Exactly. Thank you, Dr. Alam. So it's the difference between two arms. So here we are. The effect size is the difference between control and the intervention. So let's give an example. We have two diet programs. One program, when we imply it, we lose 20 kilograms. The other program, the program 2, we lose 10 kilograms. So the difference between two programs is 10. Other example, we're using a specific teaching activity. It brings improvement 10% in the examination. So the 10 kilogram difference and 10% are indicator of the claim effect size. The difference between the arm, the effect between the two arms, the difference in the size between two arms. The absolute difference between two arms is 10, because it's first we're losing 20, and the second we're losing 10, so 20 minus 10 is 10. The relative difference is the relative reduction in the test intervention. So for example, in the first program, it's 10 over 20, so it's 50%. So it gives you the ratio. In this program is 10%, in this program is 50%. So that's called the expect effect size, this difference between two arms. Now, when you combine all the factors, you will understand it way better. So again, the effect of a specific size, it estimates the difference between the two different arms. And this depends, if it's a first study, it depends on the report. It depends on the verbal claim, or it depends on the preclinical studies. So the larger effect size between two groups, you need smaller sample size. While the small effect size, you need large sample size. An example, make it easier. Smoking and lung cancer, we know the effect is very high, so we need a small sample size. While the relation between smoking and brain tumor, it's very difficult to estimate. It's very small, even if it's present. That's why to claim it, to find the result, we need very large sample size. So what are the prevalence rate in a sample size? Any thought? Anybody want to answer? What are the prevalence rate in a sample size? Remember, we're talking about sample size. Yeah, you are late, Rami. Okay, any answer, any thought? Okay, I'm going to answer. So the underlying event rate in a population is the prevalence of targeted population in whole population. It's from which we calculate the sample size. The prevalence rate of population depend on the nature. It's not by convention. It's not an assumption, because significance level and power is assumption, while the prevalence depend on the nature. It usually we use it verbally from previous, or from report, or from previous studies. Sometimes if it's the first study, then we can change the rate during the study, after we do the sample size. So now let's make it graphical so you can understand it way better. So here we have a population with different characteristics. We have different colors. So if we select the black, that's our targeted population. So if we calculate the black out of 100, the black is 58 out of 100. You see the rate is very high, which means you need, this is big size, you need small sample size. Okay, while if we select the other color, it's only 22, so the rates are very small. So we need a larger sample size. So the prevalence, which is occur by nature, affect the sample size. Now we reach to other factors that affect the sample size is the standard deviation. So anybody knows what is standard deviation? Any thoughts? Yeah, go ahead.
Standard deviation, distribution of element from the mean.
Great. Yes, you are right. From the mean, from the median, from the average, it's the stretch out of the extreme end on positive and negative from the center. So the
Yeah.
more you stretch
Yeah.
out, the larger the sample size you want. Okay? So, and I gave an example. If you get mean of 10, 9, and if numbers are range between 9 and 11, the mean will be, and the median will be 10. If the range is 1 to 20, still the median is 10. But the standard deviation from 1 to 20 is very big, while the standard deviation between 9 and 11 are very small. So let's make it graphics so you understand it better. You can see this line, or this normal distribution curve, is very wide. The extremities, or the range from positive and negative, are away from the mean, while this one is very small. The range of positive and negative end from the mean, or the median. So you can see this is small standard deviation, this is big standard deviation. So this need small sample size, while this need a very big small sample size. So example of standard deviation, we have intervention B and we have intervention A. So the intervention A, the weight range between 80 and 100. So it's small range. In intervention B, the range from 45 to 100. So this is very wide range. This is more heterogeneous. This is large standard deviation. It needs large sample size. While this is 80, the difference is only 20. So this is this is more homogeneous sample. It's a small standard deviation, and therefore you need a small sample size. The other factors that affect the sample size is the consent rate. So you have population, you determine your targeted population, and then you go and take consent. Not all the patients or patient parents will accept. So you have a percentage. And this you will know from previous studies, from your institutes, from your ethnicity, from your population, you know what is the percentage. Also, some people will be transferred. Some people will die. Some people will be discharged. Okay? Some people will withdraw their I'm sorry, it's internet unstable. I'm being disconnected again. You guys hear me?
We hear you, but we don't see the screen. Now okay.
Yeah, I'm sorry, the connection.
Okay.
And the internet is unstable. I am only using wireless internet, so my apology for that. So again, I'm going to repeat, the consent rate is when you have the population and then you select your targeted population by your inclusion criteria, you start to take consent. And you know from your institute, from your population, from your ethnicity, how many and what is the percentage of people that will say yes to the consent, how many will say no. Also, you have to consider how many will be transferred from your hospital, how many will be, for example, died, how many will be discharged home, how many will withdraw their consent. So you have to know this percentage from your previous studies, from your previous experience. So now we consider all the factors of the sample size, and now we will do the calculation. Now the method or the equation for sample size are several types. It depends on the type of the variables, and it depends on the study design. Here I will give you one example. Now how you will know? It's from the statistical software. It will tell you the equation of sample size. So you decide your study design, you decide your variables, whether dependent and independent, continuous, categorical, and so on. And then the software will tell you the equations. So we will use this equation. So M here represent the required sample size. ZA represent the significance. Z1 minus beta represent the power of the study. And gamma represent the standard deviation. And change power 2 represent the size or the effect size of the sample size. So, and again, the p-value for significance, we take it from tables. And remember, it's either two-sided or one-sided, which means the intervention can have negative and positive effect, two-sided effect, and it can be only positive or only negative if it's harmful effect. So it depends on the level of significance and whether two-sided or inside, you get your number from tables. Okay, so the Z1 minus B is by convention, as we said, the power study by convention, no reason, is 80 or 85, 90 or 95. It cannot be 100 because there means no sampling. And then you will get the numbers from tables. The standard deviation, you will get it from the standard deviation. The change or the estimate effect size is the difference between two interventions. Now, how that will be done? We will do a sample. So what is the limitation of sample size calculation? First, by convention. As Rasha was asking question, why 20? We don't know. It's by convention. So type 1 error or the significance level is by convention. Type 2 error or the power of the study is by convention. And also we are assuming the effect size from previous studies, and we are assuming the standard deviation. Okay? And remember, the sample size has always to be calculated before initiating study. And once you start to do study, you might find yourself, no, the sample size is not enough. So that's one of the limitations. But try our best not to change the sample size of starting recruiting. Also, as some of you said in the beginning of the session, is some of the sample size calculation affected by some practical issues, administration, cost, benefit, feasibility, and so on. Okay, so let's practice a sample size calculation. So now you can gather all the information because it's a lot of information. Let's assume we want to study the effect of CPAP on RDS. So that's our R1. And a group of researchers want to see its effect on RDS, and they want to compare it to surfactant administration. So we have one arm CPAP, second arm is surfactant administration. And the outcome is the percentage of FiO2 needs at 24 hours post implementing the intervention, whether it's a surfactant or CPAP. The population here is premature babies. The targeted population is premature babies with RDS. Now, the Z level, we will use 5%. The power, we will use 80%. The standard deviation estimated from previous studies. The change or the effect size is the difference of the effect between two interventions. So let's continue. So let's assume the p-value is 5% and the power is 80%. So from the table, we will use the alpha level of 1.96 because it's a two-sided study. Okay, so here. And the beta level, we will use this one. Okay, 80% because it's two-sided study. The standard deviation based from previous studies is 0.72. So the alpha change from previous study, we know the CPAP reduced the FiO2 need at 24 hours by 35%, while we know that the surfactant reduced it by 50%. So the effect of size is 50 minus 35 is 15 or 0.15. So now we have all the equations. We have the significance level, we have the power of the study, we have the standard deviation, we have the size effect. So the sample size is 362 for the CPAP arm and 362 for surfactant arm. Now we know that 10% of our population from previous study will be lost due to non-consent, due to death, due to discharge, due to transfer, which means that we need a sample size of 400 for CPAP and 400 for surfactant. Now, once we did the sample size, now we need to know how we sample. So we sample on two ways, either probability sampling. Probability sampling, when we do it, it's a random selection. So let me mute everybody because Sorry about that, because some of you is not muting himself. So probability is random selection. Probability sampling allows statistical inferences to inference the effect of sample size to the whole population. Non-probability sampling, it's non-random selection. It's based on convenience. It's based on please mute yourself, because I'm muting and you guys unmuting yourself again and again. Please mute yourself. So the non-probability is non-random selection. It's easier to be collected. And you should, yes, Sundus, you have a question.
Yes, I am asking, excuse me, if we should know the number of the sample before we and the power before we start.
The power is
the equation.
Yeah, the power is assumption. The significance is assumption. The calculation of sample size should be before enrollment of first patient. So we have to calculate the sample size before we enroll the first patient.
Okay, thank
you. Because that's, if we calculate the sample size after enrollment, then that's a bias. So how we sample? Yeah, how we sample by two methods. Probability, where we can do statistical tests and we can do statistical inferences or attribute the effect of sample size on the population, or non-probability is a convenience sample, easily sample, non-randomization, and you cannot do statistical tests on it.
Yes.
Okay, and you should clearly mention your sampling method on your methodology when you write an article. You can mute yourself on this. Okay, so let's start by simple sampling. Okay, so now we're talking about probability sampling. Probability sampling have different way of sampling. The first one is simple sampling. So every member of the population has equal chance of being selected. And the sampling should include the whole targeted population. How do you do the simple sampling? There are different techniques. You can use a number generator computer software, or you can use tables. How do you do that? Like, for example, if you have a population 100 and your sample is 45. So what you do is you give your population numbers from 1 to 100. And then you put it in your randomizer. And you tell your randomizer that you need 45 subjects. And the randomizer will randomly select 45 from your whole population. That's called simple randomizer. This has a problem. When you run the study, you will know why the problem. Because it can affect something called trending bias. Because if you have a mixture of man and woman, it can select only men, and it will not, because it's randomization. Systemic randomization is the same, but you use pattern. So you will say, I will put from 1 to 100, and I will start select every third one until I get 45. So again, I explained the systemic randomization. Okay, now the problem with that is you can skew your result. You will not get normal distribution curve. Stratified sampling also use random or systemic sampling, but you stratify the sample. An example here, you have a company that has 800 females and 200 males employees. You want to ensure that your sample reflects both gender. So what you do two stratas, one is female and one is female. Then you select by randomization, whether simple or systemic, 80 female, and from the other group you select 20 male. That's called stratified sampling. Cluster sampling is you cluster the individual, the population, to its characteristics, and then you select the group itself instead of the population themselves, called the cluster sampling. Now it's confusing, but let's make it graphical. So let's give you an example of cluster examination. You have a company has offices in 10 cities, but it's very hard to do the test on 10 cities. So you select 3 offices in 3 cities to represent it, then 10 cities. Okay, now let's do it graphical so you understand it better. Let's start with simple sampling. So this is your population, and you ask your generator to sample it randomly. Now, systemic sampling, this is your population, so you use pattern. In this pattern, every third, you're selecting every third person, every third individual. Now, the stratified sampling, you characterize or you stratified your population to their characteristic. So this color versus this color versus this color. And then you select an individual, equal individual from each group. So that's called stratified sampling. Now, cluster sampling, you make a cluster of all the characteristics, a group or character. You can see, you make a group of 3 of different characteristics, and you select the whole groups. So simple sampling, systemic sampling, stratified sampling, cluster sampling, all are probability sampling. All you can infer and you can do on the population, and you can do statistical tests. Now, the non-probability sampling, it's non-randomization. Not every individual has the same chance to be selected, but it's easier to be done. It's cheaper, but you cannot do statistical tests on it. And usually we use it for just exploratory before we do the randomization research. It's not quantitative, it's qualitative. The aim to not do null hypothesis or test hypothesis. Okay? So the first type of non-probability sampling is called convenience sampling. Those close to you, you select them. It's easy, it's inexpensive, it's very simple, no defect. So if you want to search opinion of a physician about services in your hospital after each working day, you ask your fellow doctors, not doctors, the doctors, wrong typing, on the topics. So if you're working in medicine, you go and ask the doctors in medicine about the services because they are closer to you. But in medicine, they don't represent the whole hospital because you have surgery, you have pediatric, you have obstetric, and so on. That's called convenience sampling. The other one is voluntary response sampling. So you call people by phone, and those who answer you, you will get them. Voluntary sampling. So purposive sampling is involved using their judgment to select the sample population. So you select people, for example, with specific phenomena. For example, intellectual disability. So you select people with intellectual disability and you investigate them. So and snowball sampling is you ask a person in an area who know people. So in area A, you select person A, in area B, select person B, and these A and B will guide you to the population. So let's make it graphical so you understand it better. Convenience sampling. Okay? So this is the researcher, and you will select people close to him. Convenience. Non-random. Voluntary response sampling. This is the researcher. These are the people who respond to him. He asked all the people, but he selected only the people who responded to him or her. Purposive sampling is you select people with certain characteristics. In this case, you select people with certain color. For example, certain disability or certain characteristics or certain problem. Snowball sampling, you ask a person and that person lead you to others. Okay, these are non-probability sampling. And this is convenience sampling. These you cannot do testing on it. So we've talked about sampling, calculating the sample size. Now we will talk about randomization. So the randomization depends on the, because it's a probability randomization, it's either simple, systemic, cluster, or stratified. All of them include same procedures. First, you do assignment. So each person in your, or each subject in your study, you will give ID, as you can see here. Then you hide the subject. So you do concealment. The concealment can be central. So a person in another place, in a computer, on a phone call, you call him or her, and it tells you the number. You don't know the link between the subject and the ID. Or you can hide the subject in an envelope, and you give in an opaque envelope, and you give the ID on that envelope. And then you ask an individual not included in the study, using only the ID, not knowing the subject, to do the randomization. Randomization can be generated by computer software or using certain table randomization. And you give that individual a status book, which link the subject ID to the subject, to the individual. At the end of the study, when you recruit your two arms, that person will do something called revealment, links the subject ID with the person. So this is the process of randomization, whether it's simple, systemic, cluster, or stratified. So again, randomization, a process of sampling, assignment, and concealment, sometimes called random allocation. So random allocations or sampling, first you do your sampling, you do your assignment, you do allocation, one arm or other. So first you do sampling, as we talked about sampling, then you assign a subject ID to the individual, then you will say this group of individual will receive this arm, 100 will receive this arm, and 100 will receive the other arms. Then you hide the individual by an ID. Then you ask another person to do the randomization or blinding. Randomization can be by software or table. That individual have a status book. You start your enrollment. At the end of the study, that person do the revealment. So these are my references. And I am finished. I hope that I did good job. There was a lot of problem today of the program and the internet connections. So if you guys have any questions, I am ready to answer.
Thank you, Dr. Yahya.
You're most welcome. I know it's a tough topic, but I hope I did a good job in explaining it. You're most welcome.
Thank you. Appreciate it.
You're most welcome. Any questions?
Thank you so much, Dr. Yahya. It was simple and it was interesting.
So Manal is asking, could you please repeat how to calculate same size or sample size, you mean? So calculating the sample size, you have factors. You have the significance level, you have the power of the study, you have the standard deviation, you have the effect size. Some of them, you get them from previous studies. Others of them are from convention, assumptions. You get all the numbers and you have a formula. The formula or the equation depend on your study type and your variables. And then you put these numbers and it will tell you what is your sample size. Assignment is, there is two things. There is assignment and there is allocation. Assignment is you have individuals, you have subjects. Okay, these subjects can be babies, can be human beings, can be female, anything. These subjects, you will give them an ID. A number is specific to your study. That's called assignment. Allocation, so let's say you want to recruit 400 for one arm and 400 for their one arm. So you put numbers from 1 to 400 in A and 1 to 400 in B. That's called assignment. You assign the subject to a number and then you allocate them. So you have 800, 400 for this arm and 400 to this arm. Tariq, you have a question. Tariq?
Yes, Doctor. Thank you very much for your presentation. Can you hear me, Doctor?
I do. Go ahead.
Yeah, I wanted to ask is how important in all of this process is a timeline?
Timeline
Time frame
of what?
of the study. Like if you're going to choose a study.
Timeline, it depends on the prevalence, on your resources, and your concentrate. So the timeline, it can be very short, like in survey, or it can be very long in rare diseases. Okay, and it's a difficult concentrate. I'm going to give you an example. If you want to do study on, for example, meconium aspiration, you want to do 2 arm in a meconium aspiration. Now, you know meconium aspiration is an emergency. And you know the mothers are in labile and very emotionally labile. And the parent and the father may be frustrated. So it's very hard to get consent. So the refusal rate will be very high. And if you want to do this study, any study related to the emergency intervention will be difficult. And it will be long time. It can be 3 years or 4 years. Well, other studies that only for example, an operation, elective operation, you have a good chance of time to get a good consent. And so that's one factor, concentrate. The second factor is the prevalence. So if, for example, you want to study smoking in cancer, lung cancer, you know, lots of people are smoking. So it's easy to get the sample size. But if you want to study lung cancer related to some genetic factors, you need a very big sample size. So the prevalence rate and the concentrate affect the timeline of the study. Any more questions? Any more questions? No more? So Rasha is assignment sampling frame. No, sampling frame is the process. The sampling frame, when I said, is the process from starting the assignment to allocation to blinding and randomization to revealment. This is the frame of sampling. Assignment is giving a number, a study number to the subject. That's called assignment. Allocation is dividing the population or the sample to 2 arms or 3 arms. The equations of the sample size depend on the study. There are many equations, depend on the study type. The equation will come from a software you don't need to worry about. So if you say, this is my sample size, this is my study design as a cross-sectional, these are my variables, you put it in a software, the software will give you the sample size equations. So you just need to find the significance level, the power of the study, the effect size, the prevalence, the standard deviation, and then use the equation. So you don't need to worry about the equations. The equation will be selected from a software. You cannot memorize it. Any more questions? You need to review the study, the lecture, and then you can review it on YouTube, and then you can ask me a question, and you can try to implement it. You can try to practice, generate a question, and do something. And if you have a question, if you're stuck, you can ask me on WhatsApp. I can send you a. So the most important is you practice. If no more question, I'm going to end the session. Thank you very much for the attendance. Ramadan Mubarak, and have a good night.
Good night.
Thank you very much. Thank you.
Thank you. Thank you.
Okay, Doctor.
Thank you. Bye-bye. Bye-bye.
Thank you very much. Good night.